Today, we'll take the telescope up on the mountain. We'll look at some nebulae and see what we can find about the births and deaths of stars. Hello, I'm Glenn Ward, and I've been thinking lately. I've been thinking about the births and the deaths of stars. I've been thinking about how all that happens, but I've also been thinking about what we can see ourselves up in the sky related to all this. It's kind of amazing to think about stars, and when they get old and they explode, at least if they're pretty massive, they'll explode. You know, we wouldn't be here if not for the supernovae. You know, you think about it. Many of those elements which make up your body were forged in the interior of high-mass stars. Then when the stars got old, they exploded, and they spread those new elements out through the universe. Even the shock waves from those explosions were important, because they induced the vast clouds and dust and gas out there to start coalescing into new stars and new planetary systems. Well, sometimes things just need a little nudge to get going. Stars age kind of like all living beings, you know. The thing that makes stars age isn't the degradation of cells or the DNA like it would be for our human bodies. Stars age because as the nuclear fusion in their cores fuses one element into another, they run out of the better fuel elements and they have to move on to less efficient reactions. You know, a star will start out with a reaction fusing hydrogen into helium, and that reaction works great because a lot of extra energy is released. And that extra energy provides the pressure to keep the star from just collapsing in on itself because of its gravitational, attraction. A star may be able to continue fusing hydrogen and helium for billions of years, but it will eventually burn through all the hydrogen. And it's really massive. It might fuse carbon and neon and oxygen and silicon. Those later reactions don't provide so much extra energy though, and the star is living on borrowed time once it moves past fusing its hydrogen. Eventually, there's not enough pressure being produced to support the core of the star against the gravitational contraction. And if that star is massive enough, a supernova can result when the core collapses and an incredible nuclear explosion ensues. Well, stars that are many times more massive than the Sun will explode as supernovae, some of the most exciting events in our skies. While we see supernovae going on in other galaxies all the time, in the span of a human lifetime, they're pretty rare here in the Milky Way. It's thought that some of them actually go on, but the visibility of them is blocked by clouds of dust and gas here in our galaxy. Now, when I was a boy, a supernova exploded in one of the Magellanic Clouds, which are kind of like miniature galaxies close to our Milky Way. Unfortunately, the Magellanic Clouds are in the far southern sky, and I lived too far north to see supernova of 1987. Well, that's the way it goes. But those supernovae right here in our Milky Way galaxy have been seen in centuries past. One of the most studied has been the supernova of 1054. And it's famous, because it was the progenitor of the Crab Nebula, a pulsar wind nebula in Taurus. The Crab Nebula is located up by the top of one of the bull's horns in the constellation of Taurus. Our Sun won't end its life in a violent supernova, though. It's nowhere near massive enough to explode that way. Instead, in a few billion years, it'll swell up and turn cold and red, and eventually it won't be able to hold on to its outer layers. The layers will shell off, and they'll form a pretty round planetary nebula. What's left of our Sun will continue on as a white dwarf. I think we can investigate stellar birth and death ourselves by looking into the sky with a telescope like this one. The Crab Nebula represents stellar death. We can also see the beginnings of new stars if we know where to look. One of the most famous of the nebula, the Great Nebula in Orion, represents a stellar nursery, a birthplace of stars. So we can see that out there too. As I film this, it's in the late winter, and the constellations like Orion and Taurus and some of the other favorites like Canis Major and so forth are still up there in the evening sky. So what I think we'll do, we'll take the telescope up to the mountain and we'll see it there live, what we can see of stellar birth and stellar death. Okay, so now we have a live view of Orion, one of the most familiar figures in the sky. A wonderful figure with several famous stars and several famous deep sky objects. Right here we have Rigel. You know that one, right? It's very familiar. And then up here, Betelgeuse. And over here we have Orion's bow and his left outstretched arm. And then his belt, which is very famous. And then right here we have his sword. And in his sword, right here, we have the Crab Nebula in Orion. So that's what we're going to check out to find out about stellar birth. Okay, so now we have here a live view of the Orion Nebula. Look how beautiful it is. Look at how it looks like there are petals in a flower that have opened up. What's really going on there is that the stars there in the nebula have blown out the gas and dust due to their radiation pressure, their stellar winds. And they've blown it out there. And then in the center there, look at what we have. See how bright it looks? We have a central star-forming region right there in the nebula, and it's so beautiful. Look at how beautiful it is, how it's just like a flower that's opened up in this view facing upwards, and it's like the petals of a flower have opened up, and I think that's really appropriate for such a nebula. This is a star birth region, and so the idea of they're on a satellite, but the idea of a flower opening up seems appropriate for such a region. Okay, so now what I did was I reduced the gain on the camera. We're actually looking at the same thing, but with the gain turned way down, you don't see the great petals of the flower that I mentioned before. But with the gain turned down, the central section is not blown out or overexposed, and we can see some of the stars inside there, inside the nebula, that have just formed. And these are very young stars, and it's an area known as the trapezium. It's very famous. But those are some of the young stars that we can see inside of there. Now there are other young stars inside of there that are contained within what are called Herbig Haro objects. And these are stars that are still within their cocoons there in the gas and dust. We can't see those directly, but they are there contained in some of that nebulosity that you see. But those stars there in the center of the trapezium, those are young stars that have developed enough that they have a strong enough stellar wind to blow the gas and dust out away from themselves so that we can see them. Okay, so let's try it now with the gain turned way up, and you can see here a lot of more detail in the nebula, especially in the little companion nebula there towards the bottom of the view. It's basically a part of this region as well, and the same things are going on there that are going on up in the main nebula. But if we look closely, we can just see so much detail there in the what I was calling the flower petals there. We can see so much detail there and how the gas looks kind of wispy, and it really is a case of a wind blowing against the gas and blowing it out into an open shape. It's really fascinating. It's amazing to think about this, but this is the birth of stars. These stars are being born here. It's like a nursery for stars. It's a stellar nursery. Young stars are being born, and you can just imagine the lives that they'll have as they blow out all of that gas around them and make their way out into the universe. Okay, so now we're looking at Taurus. Take a look right there. That's Aldebaran, and there we have the V shape next to the star Aldebaran. The V comes up really high, up to there, and up to there too. Now check out over here. We have the Pleiades star cluster, and then right there, that's Mars. It's just passing through. But the place we want to look is right up here by Zeta Tauri. That star is called Zeta Tauri. And right by it, there's a place right there. And you can't see it in this view, but right there where I'm pointing, that's where the Crab Nebula is located. So we're going to turn a 10-inch telescope onto that area right there. We're going to find the Crab Nebula, and then we're going to see how it looks, and we're going to see what we can learn about it by looking at it. Okay, so there we have the Crab Nebula, and this is a live view through our 10-inch telescope. There went a satellite streaking through there. But anyhow, we look at the Crab Nebula and we notice a few things. For one thing, it's very irregular in shape. It's not nice and round like a planetary nebula. Another thing too, it doesn't have some of the more beautiful glow that you tend to see in some of the star-forming regions where you have the emission nebula that are being excited by young stars. This is a pulsar wind nebula, and this nebula is being excited by a pulsar. It's a rapidly rotating neutron star. It's a little tiny star a few miles across that is rotating 30 times per second, and it's shooting out all kinds of radiation too, so it's exciting the nebula and making it glow. I feel like if you look closely, you can kind of see a crab shape. Here in Maryland, our state logo is a little crab, and it kind of looks like a small crab, sort of, if you use your imagination. But this is a remnant of the supernova of 1054. It's only been spreading out for 1,000 years, which is nothing on an astronomical time scale. So it's a very interesting object to look at. It's very young and it's very exciting, but it's also a picture of stellar death. That is the end of a massive star that went supernova 1,000 years ago, and after that explosion, the gas that spread out around it, well, that's what you can see there. So that's the Crab Nebula, an example of stellar death. Well, I just realized we have a crab right here on our scope. That's the Maryland crab. I mean, I think I can see a crab in that nebula. Well, anyhow, it was fun looking at these things. This is the first video I've made in this format. I'm going to make more, and I'm sure I'll get better at it as I go along. So thanks for watching, and bye-bye.